Hello, I'm Varsha Jenni from RV College of Engineering. These days we have a lot of data around us and processing this data is a vital task. And most of this data is unlabeled. So here clustering algorithms play a very important role. And as we all know, DBSCAN is a state-of-the-art algorithm that provides a way to deal with clusters of variable size and shape. But DBSCAN algorithm does not perform well when the dataset consists of clusters with varying density. And it also requires two parameters, that is EPS, which is the radius of each cluster, and the minimum number of points of each cluster. So here we propose an algorithm that not only identifies clusters with varying density, but also it does not require any of the parameters to be given by the user. So now the main goal of any clustering algorithm is to group data points with similarity. So we have used a Gaussian kernel function to group data which are similar. So this Gaussian kernel function gives values between 0 and 1. And if the similarity is more between 2 points, the value is higher, and if the similarity is less, then the value is lower. Here in this equation, L and P are 2 points, and sigma is the product of the standard deviations of the attributes in the dataset. So first, the unlabeled data is fed to the algorithm, and data preprocessing is done by standardizing the data. And then grid search is used to select the threshold density, that is the minimum density. This threshold density is selected on the measure of Silhouette score. And then this threshold density is fed to the adaptive clustering algorithm. From this adaptive clustering algorithm, we get our final labeled data set. Now let us see how our proposed algorithm works. The main aim of our study was to extend the already present HPCC bundle for DBSCAN. In the DBSCAN algorithm, there is a function called getNeighbors. This getNeighbors function, according to the EPS value given by the users, returns the neighbors of a particular point. We have modified this getNeighbors function to implement our algorithm. Here, the input that are required for this getNeighbors function is L, the data point, which is fed into this function through the DBSCAN function, the dataset DS, the Minpts, which is nothing but the minimum number of points in each cluster. This is taken as 10% of the data points in the dataset. Sigma, which is the product of the standard deviations of all the attributes. This sigma is required for the Gaussian kernel function. Initially, we initialize the set of all the neighbors of the data point L as a null set. And then I declare another variable called temporary threshold and set it to 0.9. I set it to 0.9 because the Gaussian kernel takes a maximum value of 1 and 0.9 is fairly near to it. Then what I do is I calculate the kernel density function for each and every point with L, and whichever points have this kernel function greater than the temporary threshold value, I consider them to be the neighbors of the data point L, and like this I find all the neighbors of L, and if the number of neighbors are greater than the minimum number of points, I group them into a cluster and return that I have found a cluster. Otherwise, I decrease the temporary threshold and repeat the procedure of finding the clusters. I repeat this procedure until the temporary threshold value reaches the threshold value found out by grid search. So as we are decreasing the temporary threshold value after each iteration, this algorithm can identify varying density clusters. And even though after reaching the threshold value, we do not find any clusters, then we declare the data point L as noise and return false. Now let us see the results obtained from this algorithm. We have compared with other approaches suggested in various papers. Here in the reference section, we have the 3 papers that we have referred to compare our algorithm. And we can see in the graph here that our algorithm, that is the hybrid approach, outperforms other algorithms, and it successfully identifies varying density clusters. It also has an advantage that it also detects clusters that are lying very close to each other, which the other algorithms fail to do. Thank you.